Hi, I'm Chris Zermeno, and I'm with the Adams family, and I'm going to run through my problem for a limiting reactant problem. So, a limiting reactant problem is when we have reactants that are giving products. So we can only have so much of products based on how much it's going to be produced from our reactants. The way that I like to remember it is, if we have peanut butter and jelly, if we only have enough for 10 slices of peanut butter but only 5 slices of jelly, we can only make 5 peanut butter and jellies because we don't have any more jelly. So our problem up here says if we have 10 grams of iron 2 oxide reacting with 40 grams of magnesium, what is the mass of iron that will be produced? So we have to start with one and then go to the other to get our answer. We'll start with our first given, which is 10 grams of iron 2 oxide. And then we have to get the weight of the iron 2 oxide. So we go for our periodic table. The molar mass of iron is going to be 55.85, and then the molar mass of oxygen is going to be 16. So 55.85 plus 16 is going to be 71.85. So we set up our conversion factor here, and I want the weight on the bottom so that I can cancel this out. So I know that 1 mole of iron 2 oxide is 71.85 grams of iron 2 oxide. And then what I want to find out is how much iron it is going to produce, because that's what the question is asking. So for that, we have to go to a molar ratio, 1 mole, and I want the mole of iron 2 oxide on the bottom so that I can cancel those out. So I'll put iron on top, 1 mole of iron 2 oxide on the bottom. And so now I'm in moles of iron. And then I want to finally go into the molar mass of iron so that I can figure out how much iron is produced. So for that, I'll set up my last conversion factor, again putting mole of iron on the bottom so that I can cancel it out. 1 mole of iron. Get the molar mass from the periodic table, 55.85 grams of iron. And that is what I'm left with, is grams of iron, because this cancels with this cancels with this cancels with this. 10 grams times 1 times 1 times 55.85. And then on the bottom, we're going to divide 71.85 times 1 times 1, so just 75.85. So we have 10 grams times 1 times 1 times 55.85 grams over 71.85. And then that's going to equal out to 7.8 grams of iron. So I'm going to write that on the side here so we don't forget. 10 grams of iron 2 oxide produces 7.8 grams of iron. The second will be a little quicker because we are just duplicating what we did in the first, but we'll have to do it with magnesium to see how much iron is produced there. So the given is 40 grams of magnesium, and we want to know how much iron is produced. So for that, we're going to get the molar mass. I want grams of magnesium on the bottom so that I can cancel out. So 1 mole of magnesium, and the molar mass from our periodic table is 24.31 grams of magnesium. And then I want to do the molar ratio, so mole of magnesium on the bottom so I can cancel out. And that when we're going to add in our our iron, because that's what we're looking for. And then our final is going to be the weight of iron. So mole on the bottom of iron, so we can cancel. And iron, 55.85 grams of iron. And that is what we're left with, is grams of iron, which is what we want to be in. So grams of magnesium cancel, moles of magnesium cancel, moles of iron cancel, and we're left in grams of iron. So 40 times 1 times 1 times 55.85 all over 24.31 times 1 times 1, so 24.31. And that's going to give us our final answer of 91.9 grams of iron. So I'll add that to the list over here. We now know that 40 grams of magnesium is going to produce 91.9 grams of iron. So we just completed the question somewhat. We'll look at our results. 10 grams of iron 2 oxide produces 7.8 grams of iron. 40 grams of magnesium produces 91.9 grams of iron. So going back to limiting reactant problems, the iron oxide appears to be the limiting reactant because it produces the less out of the both, 7.8 grams. So once the iron oxide is used up, there can no longer be any more iron produced, and our magnesium is going to be our excess reactant because it produces more. So I hope that helped, and good luck with your studies.